Hi, I'm Hee-chan Park. I'm the software designer and the programmer of Danuri XR open source 3D engine. Long time no see. Busy last month for supporting our clients and engine programming. There are some changes in my company, so I have to process some job to figure it out. I could not upload the video for almost a month. Today I'm gonna talk about recent Danuri engine updates. The update is changing projection method from standard G projection to reverse G projection. The popular modern 3D engine like Unity or Unreal, I heard that they use reverse G projection. I think almost modern 3D engine uses reverse G projection. But Danuri did not use reverse G projection. Danuri used standard traditional G projection. So recently I decided to change the Danuri projection method to reverse G because some artifacts in our content are detected from standard G projection, so we decide to change it. I was afraid to change base math library because it may affect previous content program and may make unpredicted misbehavior, so I don't want to change them. But anyway, I changed method and tested for a month. Currently, it seems it works well now. First, I will talk about what is reverse G projection, and then I will talk about the detailed working procedure to change the engine projection method from traditional method to reverse G projection. Then let's see the engine code changed for applying reverse G projection method. There are many considerations to change the projection method, and let's see together how the results are changed. First, what is a reverse G projection? Before we talk about reverse G projection, let's see traditional projection method. This is the matrix, traditional standard G perspective projection matrix. There are many variations of the matrix, depends on the graphic system. Transformation may be row major calculation or column major calculation. There can be variation of the matrix. Anyway, the result of the depth value saved to G value, it is ranged from 0.0 to 1.0. The nearest depth is 0.0 and farthest depth is 1.0. And the engine math library code look like this. This code is previous version code before the recent update. Anyway, G value is 0 to 1. The nearest value is 0. Why we changed to reverse G? There are limitations of standard G projection. The major limitation is the ratio of far plane to near plane is limited. If ratio is greater than about 1000, there may occur many artifacts. The reason why this limitation occurs because of the floating point precision problem. You can see more detailed document on the web. They say that the standard G projection method is non-linear and the floating points are not distributed equally within the range. So there can be the limitations of the ranges. There exist the limitations of the ranges, and it is very inconvenient. If the scene designer misuse or break the rule of the limitation, you can see many artifacts in the scene or clipping of the object. This is the screenshot of the artifact example. This is the XR content example. It is already delivered to our client. This is the scene, the traditional worship battle scene, the visitor experience and play. After our designer changed some camera parameters, there appears some artifacts in the scene. You can see the clipping of the rectangle. We use the unit floating point 1.0 as 1 meter. So the very big cylinder simulate far landscape. It is more than a kilometer. Then the clipping is occurred by this limitation. There are some options. First, we can make the cylinder smaller or change some camera parameters by adjusting near plane bigger or far plane smaller. Or final option is change the engine. What is reverse G? This is reverse G projection matrix. There are some modifications from the original standard G matrix. By using this matrix, you can get the near plane depth to 1.0 and far plane depth is 0.0. This is the reverse of standard G projection because near value or far value is switched. So this is the reverse of the original. There is a detailed explanation on the web. This is why reverse G method is better than standard G perspective projection. They say that when we use this formula, this method maps the depth value linear and the precision is constantly distributed. You can extend the ratio of far plane to near plane more than 100,000. It is very big enough. And also you can use infinite far plane. There is infinite option. Anyway, in our unit system, scene view range can be more than 100 kilometers. It will be very enough value for far object layout. So then we changed the engine last month. I add some alternative code. There are some checklists and to-do lists to change the reverse G method. We have to change every code using G depth value and reverse it. So there are many code to fix it. The engine code, HLSL shader code, every code dealing depth code. I have to find every code manipulating depth. Then we have to test the result. Despite all the effort, there may be unpredicted behavior. Manipulating depth is very common and core part of the engine, so we can meet the artifact we don't expect. So we need very long testing time, and anyway, we did it. Let's see the code together, what we changed one by one. This is the main alternative code for reverse G projection. We added some global switch flag while developing. This is static enumerated value switch easily between old version and new version. First, I thought that this can be changed while the engine is running, while runtime, but I found that this is impossible because if this change, shader must be recompiled. So this flag cannot be changed while the runtime. Anyway, if I change this flag, all the code switch from new or old. So I can change old version and new version. I switch it old version and new version code iteratively and test it back and forth. So also this keyword can be find the new code, alternative code on the project easily. It helps navigating the source code. There are many projection metrics, not only perspective projection, there is orthographic projection, left-handed, right-handed. Many options are there. So I have to change all. You can see the many code change. Anyway, this global static switch to new reverse G method. Many iterative works of test and fix and compare the result between old version and new version. You have to turn it on and off by this flags. Then find all the code dealing with zero depth. How about let's search the code. There are changes of new engine version of reverse G method. Sunset. Day of time. people are oh people are going home. Can see? You can see? Okay. You can see? The workers are going home. Anyway, I'm recording the video. You can see the finding files output. There are many things to change. The results say the 180 line changed. So I find all the code manipulating depths related thing. So I have to find one by one and change that. So after changing the math library, the basic operation that depth compare code. When we use DirectX depth compare function, you can see you have to reverse the depth compare. If you choose reverse G method, you have to change less equal to greater equal, because far near is reversed. When you clear the depth buffer, initialization of depth buffer, if you use 1.0 is filled with the far value, then if you use reverse G function, you have to clear with 0.0 value. So there are many clear buffer code. You have to fix that. You have to apply this condition. So there can be, you have to find one by one. You have to check the logic of shader code one by one. The perspective projection of the shader code produce G value reversed, so you have to apply the reverse option to shader code. If you return 0 depth, you have to return 1 depth when we use reverse G function. We don't provide many number of shader program, so default all-in-one shader works well. Most graphics works well. While rendering, we have to sort object by the depth. When first we check the object is transparent or not, we have to group them separately. Depth sorting algorithm uses depth, so we have to change the code. How about that? Depth sort code is depth sort code. There is a draw structure, the CPP. There is depth sort algorithm. Danuri engine generates each object characteristics to sort key. By generating sort key, then we sort sort them by this sort key. We apply quick sort. When we generate the sort key, we have to check this depth value. To change many code, I finally get the result. Because of the sunset while the recording, white balance of the camera is changed very bluish. Okay. Finally, we get the result. The scene is look like this. It's very big landscape. Mesh is imported. This map is more than a kilometer. When you use standard G projection, there are limitations using more than a kilometer size scenery. Anyway, we don't use all the ground, just we use this range. Some landscape is using fake cylinder model like this. This is more than a kilometer. We see there are no artifacts detected. So camera parameter from by this update, you can use very small near view plane and very big far view plane. This is 100 kilometer. Near view plane is 10 centimeters. So you can see no clipping, near object and far object. So the scene design worker can use very big far view plane range without any consideration. There may be some frame drop after engine update because far clipping range is very big. There is no clipping by far view plane clipping. But for our content, the number of objects are not so big, so we didn't find no frame drops after this update. Okay, today we reviewed the recent major update of Danuri engine. Next time, let's talk about another technical issue that I want to talk about. Okay, thanks for watching. See you later.